Hey guys, so in this video we're going to be talking about the normal distribution. So the normal distribution is a unique distribution which is very useful and can be used as a probability density function. However, it is unique and has specific properties which I'll go through and explain. So the first thing is looking at it, the normal distribution always has a bell curve shape. So as you can see, this is a bell curve, and it also is symmetrical. Now it's symmetrical about a particular point though. So as you can see, it's symmetrical. And if we're, depending on what the variance is, it may even look more bell-shaped. However, it's symmetrical about its mean, and that's quite important. So that's its mean or its expected value, and then it's symmetric on both sides and has a bell shape structure. So bell shape, and you can see it here. So it has a mean obviously equal to there, and it has a standard deviation equal to that, which whatever the standard deviation is. And then you can see that what is the mode? Well, the mode is the most frequently occurring x value. So you can sort of think about these ones as x. So it's the most frequently occurring x. And if you look at this, the bell shape, it's always going to be at the top of the turning point. The top of the turning point is also the mean. So we can say that here is the mode. And then the median is also at this point as well. So that means you have the mean, median, and mode all at this symmetrical point. So that's a very important observation, that the mean is equal to the mode, which is equal to the median. So there is the median. And this distribution is actually occurs a lot in life, and you'll see it in lots of different scenarios, such as battery life. A lot of the time for exam results, they like having a bell curve. And a bell curve is useful because you have the mean, median, mode all in the center, and then most people are within this range of x, depending on the standard, this range relatively close, and then on either side you have some sort of anomalies, and down here you have some outliers that are very far away. However, most of them are centered around this center point, and it is easy to change how much variance you want by literally just changing the standard deviation. Now, what this happens here is these two n bits actually continue on. Now, when you draw arrows, you shouldn't cross the axis, so that's why I didn't draw arrows there. But what you should think is this line keeps on going and never approaches the axis, but it keeps on going sort of forever. And then, so for this, in regards to probability density function, you can sort of think about the normal distribution as being the infinity to the negative infinity. So it does keep going. So it does keep going, and you can find the probability of x when it is huge and huge and huge. But the thing is, as you can see, it gets closer and closer to the x value, and so this means that it is less and less likely to be those values, and to a point where it is practically zero chance. However, the chance is still there, and that's a life scenario. If you're talking about battery life, let's say the mean is 20 hours. Obviously, the chance of it having 50 hours is very, very small, but there is a very, very slim chance that it may last for that 50 hours. So the normal distribution, I already said, can be thought of as a probability density function, and that means that its total area underneath must equal 1, and that's because the area is equal to the probability. And the equation of the normal distribution is fx is equal to 1 on the standard deviation square root of 2 pi e to the negative half x minus the mean over the standard deviation squared. So it is quite a complicated formula, and it is useful to know. However, I wouldn't say it is necessary to memorize. However, especially in your tech active, book, or if you can allow the book into the exam or test, definitely have this formula on it. And then you will see later how this formula is used when we have to use a normal distribution in actual questions. So you see there, so fx is equal to that. And apart from the standard deviation, which changes here and here, and obviously the mean, which changes here, the actual formula stays constant, and that's why you always have this bell-shaped structure. So what are the effects of changing the mean and median? So the two things you can change. So the mean and the standard deviation, so the variance. So if you change the mean, let's say you shift it and you increase the mean, then that means the mean is now going to shift over here. And we're now going to have the mean, median, mode, and the turning point at this point up here. And then the graph will look something like this. So obviously the drawing isn't great, but it's supposed to be a symmetric bell-shaped curve. So the shape stays the same, but the mean moves up. Then when you change the standard deviation, you are changing the variance and you are changing the spread. So it's always important to think of the standard deviation as the spread. So if you're making the standard deviation smaller, then what we're going to see is that the spread will decrease. You see that it becomes more more narrow, like that, for example. And if it was wider, then you may see it be like more like that if the standard deviation increased. Now, of course, it's always symmetrical and it's always bell-shaped. However, it just might spread out more, or it might become thinner near the middle. So seeing how this applies to the probability density function and how the normal distribution can be used, you'd have infinity to negative infinity, 1 on theta 2 pi times e to the negative half x minus the mean over the standard deviation. And just look at that term for a second because it will be used in later videos, and that must equal 1. And therefore the probability of A between B is equal to B on A fx dx. And you can see that's fx, and fx is there. So most of the things we've been talking about in the continuous distribution also apply to the normal distribution as it is a continuous distribution. So for example, the probability of A is just equal to 0. You can't find an exact point, it has to be between an interval. Now the reason is, why did I say the formula is useful, obviously, but is not essential? Well, the reason for this is that we normally, when we use this normal distribution, is we convert it to the standard normal distribution, which I'll do in a later video. However, for now, you just understand what the normal distribution is and its main characteristics. Now, as it is a distribution, remember that the 68% rule applies for the mean plus or minus 1 standard deviation, and then you have the 95%, which is the mean plus or minus 2 standard deviations. And you can also have the other one where you have plus or minus 3 standard deviations, which is approximately 99.7%. So you can see that once you go from 3 standard deviations away from the mean, then most of the observations are covered. And then just to emphasize, these are approximations. So depending on the sample size, you may not exactly get this, but it will be fairly close. So a final point is that not all distributions are normal. So after doing questions, you may start to get used to the normal distribution, and you may start to, whenever you see questions and you see, oh, there's a mean and there's a standard deviation, oh, it's a normal distribution, it's a standard normal distribution. But this is not always the case. So you do have to check, is it a normal distribution? And if it is, you can treat it like one, but if it isn't, then you always have to treat it like it isn't one. And then it's not necessarily bell-shaped, it's not necessarily symmetrical, and the mean doesn't necessarily equal the mean and the mode. So there are lots of content in this lecture with regards to the normal distribution. However, a lot of it, if you can just remember the shape of the bell curve, then you don't necessarily have to memorize that it's symmetrical, as you can see that it is symmetrical. And rather than memorizing the mean and the median and the mode are all equal, think about it. Well, the highest probability is going to be the mode, and that is also at the center, and the center is the mean, and then this is also the median. Now, the normal distribution is often used to look at populations and samples. So the population is when the data encompasses all the population, and rather a sample you can sort of think is a segment of the population. So we normally just assume that it's population typically in this course. However, there is a difference. So in population, the mean is equal to the mean there, so that's simple, and the standard deviation is equal to that. However, if we are looking at a sample, so this is a segment of the population, so it's not the entire population, it's rather just a segment, then we'll have that the mean is equal to x bar, so x with a bar on top, and the standard deviation is equal to s. And the reason for this is that these are not necessarily going to be the same. If you take a whole population of 1 million people, then you may get a different mean compared to just taking a sample of 100 people from that population.